I just want to put together a short video on the looking at arithmetic sequences and series, which is the lesson for today. This first page here, or first slide, is the rule for arithmetic sequences, which you should already know from yesterday. Remembering that a sub n is the nth term, that a sub 1 is the first term, n is just the number term that you're looking for, and d is the common difference. Remember, that's the number that you add or subtract each time to get the next term in the sequence, okay? These are problems like what we did yesterday. So I don't want to spend too much time on these, but you could write the rule. All you need to write a rule is the first term and the common difference, okay? So let's skip over those and let's go right to the new kinds of examples here. So one term of an arithmetic sequence is a sub 19 equals 48. The common difference is d equals 3. So what I want to do is write a rule for the nth term. Okay, notice that I said I need two things. I need the first term and the common difference. I don't have the first term. So what I'm going to do then is use this formula to figure out what the first term is. Okay, so we'll write it out here. A sub n, or a sub 19, is equal to the first term, which we don't know, plus n minus 1 times d, the common difference. Okay, let's plug in what we know here. We know the 19th term is equal to 48, so I'll put in 48. I know the first term is what I'm looking for, so I'll leave it as a sub 1. If I put in 48, that means n has to be 19, because it's the 19th term, so this is my n. So it's 19 minus 1 times d, which is the common difference, which we know is 3. Okay, so this would be 48 equals a sub 1 plus, and this is 18 times 3, which is 54. Right, and then if we subtract 54 from both sides, we get a sub 1 is equal to negative 6. Okay, so now that we've got the first term, we can write the rule. The rule is a sub n is equal to negative 6 plus n minus 1 times 3. So let's move on to the next slide here. Okay, suppose two terms in an arithmetic sequence are a sub 8 equals 21, a sub 27 equals 97 on the rule for the nth term. So what we're going to do on this is, you'll notice we don't know d, and we also don't know the first term. So the way we're going to approach this is we're going to figure out d by doing this. We're going to take d, and that's going to be equal to the second y value minus the first y value, so 97 minus 21, divided by the whatever term number it is, so 27 minus 8. So 27 minus 8. You might notice this looks a lot like the slope formula. That's because arithmetic sequences have linear behavior. Okay, so like if we were to graph them, they would make a straight line. And so we can use the slope formula to find the common difference. And so this is definitely something you want in your notes. So this is going to be 76 divided by 19, which simplifies to be 4. So there's your common difference, is 4. Now we need to find the first term, but we can do that using either one of these terms. So let's draw a little line here, and we'll do that. So let's use the first one here. So the 8th term, so we'll go 21 is equal to the first term, which we don't know, plus n minus 1. Well, we use the 8th term, so n is 8 minus 1 times the common difference, which is 4. So this will be 7 times 4, which is 28. A sub 1 is negative 7 is equal to a sub 1. Okay, so there's your first term. And then since we have the first term and the common difference, that's 4, we could write a rule. A sub n equals negative 7 plus n minus 1 times 4. Okay, let's talk about sigma notation real quick. So you've got this in your notes, on your note sheet there. Sigma notation is just a way to write a series, okay? And a series all a series is a sum of a sequence. So basically what you do is you take all the numbers in a sequence, or a certain group of numbers in a sequence, and you add them up. That's what a series is. Okay, it's a sum of a sequence. Okay, and in sigma notation, basically all sigma notation does is it says, hey, add up whatever term it starts with at the bottom of the sigma up to the top of the sigma. That's the number of terms that you want added up to, right? And then this is this f of k. This is the rule. We've been finding rules for sequences. That's the rule for the sequence. Okay, so in this example they give you, what this is saying take the first term in the sequence, k equals 1, so the first term in the sequence, and add up the first 12 terms in the sequence. Okay, so first term to the 12th term in the sequence. Okay? And that's how you can find the sum of that group of numbers. Right? So that's a sigma notation. It starts from the bottom term, whatever it is. It could be 1, could be starting at 3, whatever, up to the top term. You add up all of those numbers. That's what a series is. Okay? So let's actually do one of these. All right, here's the formula to find the sum of the first n terms in a sequence. Okay, so I don't want to spend too much time on this. All of this stuff means the same thing as it did in the other formula. So n is the nth term, or n is the numbered term, right? A sub 1 is the first term, a sub n, those n's match, those are the same. And s sub n just means the sum, okay? So s sub n means the sum. All right, so let's find the sum of this sequence here. So what this is saying is it says add up the first 20 terms. So from term 1 up to term 20. And here's the rule. Okay, so I'll write that. That's the rule. Okay. There's two ways that you can do this. You can do this either with the formula or in the calculator. I'll show you the formula first, and then I'll show you the calculator. So what I'm going to do is take everything and plug it into the formula that gives me the sum over here. So what is the first term? Well, a sub 1 is going to be equal to 3 plus 5 times 1. Okay, I'm just putting in 1. This example uses I, but usually like K or something. But you just plug in the 1. That'll give you the first term. This is 3 plus 5, which is 8. Okay? And then we're going to put in a sub n. Now, in this one, it's the nth term, and that's whatever you're going up to. So this one, so it's basically, you could write on there that it's the last term. The a sub n is the last term. So we'll find a sub n, which in this one is a sub 20. Okay, so that's 3 plus 5 times 20. And that's 103. Okay? And once you've got those two things, you've got everything that you need to find the sum. Right? So all we'll do for s sub n is we'll go, all right, n, which is 20. That n matches with whatever you're going up to. We'll put in 20, and then we'll have on top a sub 1, which was 8, plus 103, all divided by 2. Okay? And 8 plus 103 is 111 divided by 2 is 55.5 times 20. So 55.5 times 20, 1,000. 110. Okay, and that's how you find the sum. Let me show you how to do this on the calculator real quick. Okay, on the calculator, there's a command called sequence. In just a second, this video is going to show you where the sequence command is. But notice when you type in sequence, which will list out the numbers in a sequence, you have to put the rule, then the variable, then which term you want to start with, and then which term you want to end with. So let's watch how we do this, how we do a sum. Okay, notice the sigma notation up here. This is going to go from the third to the fifth term. So we're going to add up the third to the fifth term. And the rule isn't arithmetic, but it doesn't matter. So we'll see, here we go, second, stat, and the list. And then down to sum, which is number 5. then second, stat, and OPS, the sequence. So we're doing the sum of a sequence, and we have to put in the rule. So 2 raised to the x. You always put in x regardless of whether the book has k or n or whatever. So you put in the rule, then you put in x. You always put in the variable that you're using, and then wherever you're starting from, or wherever you're ending. So from 3 up to 5. Hit enter, and it will find the sum. Okay, so what you should do now is you should try that for the problem that we just did, and try putting that in your calculator and see if you can get 1,110. And so that's it for finding the sum of a sequence. Those are, remember, called series, and then also those other sequence type of problems.